Okay, so we're going to pick up where we left off last week. We had just proved that the three interior angles of a triangle summed to 180 degrees. And now we want to use those other two half sheets of paper that you have to prove that the four interior angles of a quadrilateral sum to 360 degrees. So I'm going to need you to get out your half sheets of paper, and I need you to draw a quadrilateral and cut it out. It'd be best to start out with a convex quadrilateral like I have here in this picture. Pause the video until you get it cut out and label your angles 1, 2, 3, 4. Okay, hopefully you have your quadrilateral now cut out. I need you to do exactly as we did last week with our triangle. Rip apart those angles. Should look something like this. And then, once you have your angles ripped apart, go ahead and put them together to show that hopefully they equal the 360 degrees we wanted them to. There's my angles put together. What else do we know that is 360 degrees? That's right, a circle. Your four angles form a circle to be 360 degrees. So you just showed that the four angles, interior angles, of a quadrilateral sum to 360 degrees. Now, my question to you is, will this work with a concave quadrilateral as well? Can you show that the four interior angles of a concave quadrilateral still sum to 360 degrees? Let's go ahead and see. This is what your other half sheet of paper is for. On your other sheet of half paper, go ahead, draw and cut out a concave quadrilateral. Again, pause the video until you have it cut out and your angles labeled. Okay, hopefully you now have it cut out. Go ahead, rip apart the angles just like before. Now, you need to put the angles together, hopefully to form a circle again, because we still want them to sum to 360 degrees. If you did it correctly, they should still form a perfect circle there. You can see that right there. Circle. Great job. Remember, though, we learned in class last week that this doesn't actually qualify as a proof. This just shows that, hey, this works out. It's a cool observation. Great strategy to show your elementary school students that this is going to work. But we need an actual proof. So that's going to be on our last slide here. So for my proof, I'm going to just draw a normal convex quadrilateral. Doesn't matter if it's a rectangle, square, kite, rhombus, whatever. Technically, you could also do this with a concave quadrilateral. And I'm going to go ahead and I'm going to prove why the four interior angles of a quadrilateral sum to 360 degrees. In order to do this proof, though, I'm going to use exactly the same proof that we did last week with the triangles. I already proved that the three interior angles of a triangle sum to 180 degrees. So look at this. I can go ahead, draw in a diagonal between any of the two vertices. You have to be a little bit more careful if you have your concave quadrilateral. You can't choose any two vertices because you might go outside your shape. But for a convex quadrilateral, you can choose any two vertices. Draw in that segment to make two triangles. Think about this now. We know that this triangle's interior angles right here, 1, 2, 3, sum to 180 degrees. I also know that this triangle interior angles also sum to 180 degrees. So if I add the first triangle's angles, 180 degrees, plus the second triangle's interior angles, you will see that I have all of the interior angles of my quadrilateral accounted for. And 180 degrees plus 180 degrees will equal 360 degrees. No parallel lines, transversals, or any of that needed. I can just resort back to an earlier proof that we've done. part of the homework, which I will be posting on D2L in case you've lost it or that you already have, is to prove for higher numbers of sides of polygons what their internal angles will sum to. For example, what do the 5 interior angles of a pentagon sum to? What do the 6 interior angles of a hexagon sum to? If you need some help, feel free to think back to this particular proof. Think about how you could use perhaps the 3 interior angles of some sort of a triangle to figure out your answer. I will see you all on Thursday with your completely finished homework. Have a wonderful cold day.